So I'm going to get started. It's just the three of us today, so feel free to interrupt at any time, ask extra questions, and here we go. So as you know, we've got the iDESIGN team, we've got Andy and Mario, our co-founders. Sarah's with us today. She is our marketing guru, and then we do have different reps. I'm your rep because I do all of Canada sales, but we do have Scott, Brett, and Stephen, which have split up the United States of America. I always like to highlight that we are an educational reseller. So yes, our primary product, our favorite product is VEX, but we also do carry a line of 3D printers, laser cutters, some smaller robotics systems, as well as software. So today what we're going to do is we're going to look at the VEX V5 kit. So today we're going to focus on the hardware. I've already done the software one. I believe we have a recording of that one for you. And then we're going to do a quick overview of the VEX program itself. We're going to talk a little bit about the STEM Labs and a little bit about the VEX Robotics competition. So basically the STEM Labs are for classroom and the robotics competition is obviously for extracurricular or competition. So a lot of the program focuses around this particular robot, which is the Clawbot. And I got the handy dandy little guy right here. So it's a very versatile robot, easy for the students to build. And all the STEM labs actually go with this particular robot. It's also a great robot to get the students started with VEX. Even if you're running a competition team, it's a great starting point because they learn how everything fits together. For all of the VEX robot builds, there's really easy to follow guides. And as you can see, they're well labeled. They show you exactly where everything should go. And they even have animations. So this is a new part. I don't know if you've ever worked with VEX before, but when I started with VEX, they didn't have this piece. And basically it's a black plastic piece. And what it does is it allows you to use one bolt or screw to hold two pieces together. So when I started with VEX, we never had these. We used to actually have to put 4 separate bolts through to hold it tight. And then we'd actually have to try to line it up so it was square. So when VEX came out with this, it was a real game changer. It also makes it really easy if the students need to take something apart to make changes, etc. So as I mentioned, there are a large number of guides of different robot builds that your students can build, and they don't have to build the entire robot. These are also a great resource if students want to look at how something works. For instance, the Robot Crunch has an intake mechanism. So they can look at that, and basically it's rollers that spin to pull objects into the robot. So if they're interested in how a different mechanism works, they don't have to build the entire robot. They can open up these guides, the build instructions, go through and see how the actual engineers at VEX tackled that exact project. So now we're going to dive into the hardware. So of course, the most important component of VEX Robotics and what makes it really shine is the actual VEX Brain. So the Brain can hold 8 different user programs, which means your students can actually code 8 different programs and store them all at the same time inside the Brain. It also has a number of built-in VEX programs. So simple drive. Students can actually build a robot and drive it without doing any coding. They can click on drive, they can customize it, they can change what buttons do which joysticks work, and they can drive or test their creation before they get to coding. So the idea here is they do the build, they do the engineering. Once the robot is working perfectly, that's when they go to coding. So it eliminates the problem of is it the robot or is it the code? Because using the controller and the built-in software, they can actually test out all of their creations. They can also run practice matches. So that's really great, whether you're in the classroom or whether you're doing the competition, is you can actually set a timer. So a lot of the challenge I like to do with my students revolves around the 1-minute timer, and they've got 1 minute for whatever challenge it is. And then what's great is that if they run it through the V5 Brain, the robot shuts off automatically. So nobody needs a stopwatch, etc. Of course, it's multi-language. You can change themes, backlighting, the screen rotation if you have to mount it in a different orientation, etc. Like all electronic devices, the VEX robot V5 Brain does have firmware. And for that matter, so does the controller, so does the battery, etc. What's great about it now is there's a new way to update it. So we used to have to actually download a separate piece of software called the V5 firmware utility. And what we would do is we'd have to download this on a Windows or Mac computer, connect it to the robot, and then it would check. You'll see on this example here, it was version 1.0.7, and it says version 1.0.10 is now available. And it was as simple as clicking the Update Now button. Just like all computer software, the updating firmware bar would slowly go across. And then when it's done, it would tell you to power cycle the brain. Fortunately for us now, this is done right in the software, and VEX's latest update, it works on Chromebooks, it works on all of the different devices. So when you actually connect the robot to the software, where it shows the connection, the brain icon will either be orange or green. Green means you're good to go. Orange means it'll still work, it's connected, but there is an update available. And if you click on that orange icon, it actually gives you the option, hey, do you want to update your firmware? And it will do it right inside the VEX Code software. So you no longer need a separate piece of software to download. One of the great upgrades with the new V5 system is the battery. Not only is it far more powerful, but it actually powers up to 10 motors at 100% power until it's dead. So to explain how that works, the old VEX system used 7.2 volt batteries and 7.2 volt motors. So what would happen is as the battery went down and got to 7 volts or 6.5 volts, the motors would no longer be getting full power. And that made it really challenging, not only when driving, but especially with the coding. So when VEX redesigned the system, they still use a 7.2 volt battery, but the motors are 5 volt. So as long as that battery is above 5 volts, the motors are getting full power. So that is really great. Another thing I love about this is you can actually charge the battery while the V5 Brain is on. So while I've got this robot sitting on my desk, I can be working on it. I can be coding the arm and the claw. As long as I'm not driving around, I can actually leave it plugged in so that battery is charging. And of course, it's a smart battery. It will not overcharge. It'll charge itself up until it's ready. The reason I still talk about the V5 firmware utility is because there is a part of it we still use. If you have older batteries or want to test any of your batteries, if you've got students saying this battery doesn't seem to be working good, there is a battery utility built into this. So you need to download this software. Again, it only works on Windows and Mac. We suggest teachers having it on their own computer or their school computer if it's a Windows machine. And basically what you do is you click on the battery medic icon, and this screen will actually show up on the V5 Brain. So this doesn't show up on your computer, but the V5 Brain will show up this screen. Everything green is good. If you see red like this, then you know, for in this case, cell 3 has gone bad. And if the batteries are still under warranty, all you need to do is grab a cell phone or something, take a snapshot of that, email it to me, and that's what VEX requires for any battery warranty issues. But it's also a great way to check on the battery and see what kind of shape they're in, especially before competitions. Next is the controller. It's got an internal battery and it's designed to last for 10 hours. So the idea with the controller is the battery will last an entire day for competitions. It will also last quite a few classes in the classroom. Now, when you watch the video where I talk about coding, the one thing I recommend is rather than taking this USB cable and plugging, unplugging into the robot, you have the option of plugging it into the controller. And now the system will actually use the wireless system between the controller and the robot to do all of the coding. The dual purpose of that is, one, your controller is always fully charged. The cord's long enough that you can still drive the robot around. It's about 6 feet long. So students can still use it, drive the robot, test the robot, etc. And the fact that you're not constantly plugging, unplugging the robot is also a big bonus, especially with micro USBs. It also means that students can actually leave the robot on the field or on the floor, wherever they're working, and still put new code in and test. From the controller, they can start and stop programs remotely. So they can take a look and they can choose either the built-in programs or they can choose which code. Remember, they can store up to 8 programs. They can choose any of those 8 programs and run it directly from the controller. They can also send data and text to the screen. So if they're working on something, if they want to know what angle something's at or what a sensor's reading, they can actually really easy in the code say print whatever data to the controller, and it will show up right on the controller's LCD screen. So it's a great way, especially for programmers. They love it to be able to get that feedback. The V5 radio is great. It's a standalone radio, which means it's a separate piece. It connects with the same cables as all the other accessories, and you can plug it into any one of the 21 smart ports. And it can be mounted anywhere. Saying that, we want to mount it somewhere where it's going to be safe, where it's not going to get hit by any objects, but also where it's not really close to a motor or the brain or anything like that, where it might get any interference. The V5 smart motor is exactly how it sounds. It's a smart motor. So it's not just a motor that we can turn on and turn off. It actually has an internal circuit board with a microcontroller that gives us all of this data. So it knows how many revolutions it's done. It knows how many degrees it's turned. It knows what speed it's turning. It knows how much power in watts it's using, and how much torque in Newton meters it's putting out. And all of these sensors are really easy to use in the VEX Code software. They all have their own block, and it's just a matter of dragging and dropping, and your students can use any of this data, or they can code the motor to say, hey, turn 90 degrees or turn 3 revolutions. So it really changes the way they work, especially when the students get to coding. Another huge change for the V5 motors was these internal cartridges. So with the older motors, we used to have to build transmissions, gearboxes, to get different speeds. Now it's as easy as undoing the 4 screws on the top, popping the cap off, and you can simply take the cartridge out and change cartridges. There's also a nice little window in the motor, which you can see through, so you can see if it's a blue, green, or red cartridge. So for instance, these high torque cartridges, 36:1. So what the beauty is, we get 100 RPM instead of the standard 200. So it goes at half the speed. So for things like arms and claws and mechanisms, that's great. We want to slow them down so they're easier to control. But when we do the 18:1 to the 36:1, we not only get half the speed, we also get double the torque or double the power, which means that whatever the students are building, by putting the right gear cartridge in, it's really going to benefit how well it works, how strong it is, and how reliable. The VEX V5 also has 3-wire ports, and these are great for legacy sensor or some of the new sensor. And these are basically the same types of sensors as students would be familiar with Arduino and microbit and things like that, where there's a power, a ground, and an analog or digital output. There are 8 different ports that they can use for those sensors. There is also an expander if you wanted to hook up more sensors. Now, that being said, most of these sensors don't really need to be used for competition because it's all built in now. There's built-in sensors in the motors, etc. But if you are working with students and you want them to understand how these work and how to code them and how the feedback works, this is also a great way to introduce them. One of my favorite sensors is the VEX V5 vision sensor. Now, vision sensor is a little bit misleading. It's basically a camera, and it keeps track of objects. So in this case, you can see in the picture, it's keeping track of all those objects, and it keeps track of them by color. So it doesn't know that the red ball is different than the red square, but it can tell you what color it is, how many it sees, what size it is, and also where it is in the XY axis, so where it is in relation to the robot. So this is a really great, powerful sensor if you're working with students, especially if you want to do lessons on something like self-driving cars or on factory automation, where the robot needs to go and actually identify something and then work with it or avoid it, etc. It's also really easy to set up. You actually set it up, you plug it in separately with the USB cable, and you basically just drag and drop and tell it this is the color, this is the object, etc., and it'll keep track of them. And again, very easy to use with the block coding. One of the most powerful sensors is the V5 inertial sensor. And what this is, it's a gyroscope and an accelerometer. So a gyroscope is basically a digital compass. And what this does is this allows you to code the robot. So when it's driving around, the turns are going to be precise. If you tell it to turn left 90 degrees, it's going to use the V5 inertial sensor or the gyro, and it's actually going to measure how far I turn. So if you tell it to turn 90 degrees, it's going to start to turn and it's going to say, are we there yet? Are we there yet? Okay, yes, now we're at 90 degrees. It will even say, oh, we went a little too far, and it will correct. If you don't have the V5 inertial sensor, then the analogy I use with my students is stand up, close your eyes, turn 90 degrees to the left. You're going to get close, but it's not going to be the same every time. Now, these sensors did not come with any of the VEX kits because they were developed after VEX released the V5 kits, so they do need to be purchased separately. There's also an accelerometer, and basically an accelerometer is exactly like it sounds. It measures acceleration and deceleration. So to put that into terms, you can actually say in your code, if accelerometer x-axis is greater than stop, which means if the robot were to bump into something, the accelerometer would say, wow, we've just decelerated at this rate, and you can actually tell if the robot has ran into something, bumped into something, etc. So again, really powerful sensor, especially if you're teaching students about real world robotics. There are also a bunch of new sensors. There's the optical sensor, and you can see it detects colors. There's a new distance sensor, which is actually a laser rangefinder. So again, very, very accurate. So you could use that to see if there's something in the claw. You can use it to see how far the robot is from something, etc. There's also the V5 rotation sensor. We don't see this used a lot because the motors do have the encoders built into them. So rather than adding a separate sensor and having to code it, you can just use what's built into the motor. But again, if you're teaching students these skills, it can be a great add-on. And again, the V5 3-wire expander. So what it does is it gives you an extra 8 3-wire ports, which means that you would have a total of 16 3-wire ports. I have no idea why anybody would ever need that, but I'm sure somebody has. The newest one is the VEX GPS sensor, and GPS doesn't stand for global positioning like on our phones or in our cars. It's actually the game positioning system. So for this to work, you actually have to have a proper VEX field, and there is actually like a checkerboard pattern that you have to attach to the field, and then the sensor is able to read basically almost like a QR code off the walls, and then it knows where it is on the field. This is brand new, so I haven't seen it in action as of yet. I know they did beta testing with it last year, and some of the teams were raving about how well it works. We're going to move to STEM Labs, but before I move to that, do you have any questions about any of the hardware, anything to do with the robots, etc.? No, all good? All right.
I just opened the boxes, so
excellent.
I might be telling you next week, Dean.
And that's okay. That's why I'm here. This is perfect timing. So again, STEM Labs are a great way to get started, whether you're learning yourself, getting ready to bring it into the classroom, or whether you're just going to dive right into the deep end with the students, which is sometimes a lot more fun, and they'll more than likely be happy to teach you about it. You can just grab any one of these, and again, they are labeled really well, whether they're math, engineering, coding, and just get the students started with the robots. They're step-by-step. They teach the students which robot to build, how to build it, and then they go through what the exercise is. And of course, all of these are available for free on the VEX Robotics site, and you want to make sure that you sign into the teacher portal to get all the extra resources. So this is a list of the resources in the teachers portal. So there's pacing guides. What's great about these is we understand that not every school can run an 18-week course. So there's a 6-week course, a 12-week course, etc. And it's just basically a guide for you. They're also all in Google Docs, so you can make your own copy, make your own notes, modify it however you want. There's the STEM Lab material list. All of the build instructions are found here, marking rubrics, checklists, everything you could ever want, and some stuff that you might not even use. Keep in mind that the VEX Certified Educators program is free of charge. So if you really, once you get started with V5, if you really wanted to dive in and test your knowledge and learn a little bit more, you can sign up. It's an online course. You do it at your own pace. It's simple exercises, lessons, and then of course at the end, once you're ready, you can pass the exam and become a VEX V5 certified educator. And again, that's free of charge. So I think the last thing we're going to talk about today is the VEX competition. Penny, are you planning on having your students compete, or is this more for classroom? I know you've got a lot of kits.
Yeah, it's more for classroom at the moment.
Yep.
I'm not opposed to competitions.
Right. So what I would recommend for this year is you don't want to dive in too much.
Me doing it with my grade 10.
Right. So what you want to do is probably do some classroom. And what I find works the best is if you have your own competitions, and they don't have to be anything crazy. One of my favorites, I call it the Recycle Rush. And basically I get empty water bottles and either a cardboard box or a small blue bin. And using the ClawBot, students need to pick up the empty water bottles and put them in the recycling bin. So very, very simple. When they start driving, I give them 1 minute. So in 1 minute, how many water bottles can they put in the blue box? And you'll be shocked because so far the record that I found is 3. The empty water bottles, you got to be very gentle. You got to be very careful. And students tend to try to rush it, knock them over. They're rolling around. So it is a really good challenge for them. Once they've done it driving a few times, then I like to say, okay, get some electrical tape or some tape, put some X's on the floor where the bottles go, and now get them to code it. And they have to code the robot to do the exact same challenge. And what you'll find is with coding, they can usually do more bottles in a minute than they can with driving. And that's because it's consistency, which explains to them why so many companies are choosing automation over human workers. It's not just because it's cheaper, it's because it's more accurate. And it's not that the jobs are going away, they're just changing into higher tech jobs, which leads them a segue into, hey, do you know what kind of careers there are with robotics? And this is why. So things like that. I mean, if you're just starting out, one of the other things I do is they can just build the basic robot, which is just the drive base, and set up a maze and have them code the robot to make it through the maze, you know, without knocking things over. You can just tape the maze out on the floor. Or if you don't have that, you know, you can just set something up in the classroom where they've got to drive down a row of desks over and back. If you're one of those lucky with the classroom with the double doors, send them out into the hallway down and back in the other door. Just have fun with it. They're having fun, you're having fun. And one thing I recommend is you'll find the students that really gravitate toward this. And if you can, as a field trip or send them on their own, find a VEX competition near you and go and visit this year. Just go as a spectator, see what's going on, talk to some of the other teams, and that'll give you a real good indication of what the competitions are about, the scale that they're on. And you'll also understand that there's a really vast array of the types of robot. There's lots of teams that are just starting out that build a nice simple robot. And then there's other teams that build obviously more complex robots. And that's really important for your students to understand. Because one of the things I find, especially these days with students, is they really don't grasp the concept that you get out what you put in. So if they have that idea where, yeah, we're going to build a robot and we're going to go to provincials and we're going to go to worlds, they need to understand that that takes a considerable amount more time than just putting a robot together, going to competition, learning, and having fun. So again, there's high school competitions for all of Ontario. There's lots in the Toronto area. We do also have provincials. Previously they've been held down in St. Catharines. I'm not sure where they'll be held this year. And then the competition is actually broken up into 2 separate types of events. One is the teamwork challenge, which you can see in the photo here, where there's 4 robots on the field. So what you do is you get randomly paired up with another team. So you've got your robot and their robot working together against another 2 robots that have been paired together. And they call that the teamwork challenge. And then there's also skills matches. And that's where you go to usually a separate field at the same event. And it's just your robot. And you get to do driving skills, so driving around, seeing how much you can do, and then programming skills, where the students basically hit go, and the robot has to do everything autonomously, and then they add those 2 scores together, so they're weighted 50-50. So you can understand how important coding is, and then it goes from there. Looks like Penny's grabbing her power adapter. We'll give her a minute to plug it in. like laptop batteries have a mind of their own. If it's like mine, it goes from 50% to 12% in about 3 minutes. Yep, exactly. So obviously, once you get a competitive team going, the goal is to get to VEX Worlds. I've never been to VEX Worlds. My teams have never made it that far. We have made provincials. I don't get to go to VEX Worlds because somebody's got to stay home and answer the phones for iDESIGN, but it is the biggest robotics competition in the world. So it's a great place for students to see that they're not weird, they're not strange. It's all like-minded students. And there's also a lot of commercial involvement from companies, and they're basically looking for the type of talent that these competitions bring. So again, that's VEX Worlds. The last one was held in 2019. Obviously, last year it had to be done remotely due to COVID, and we're going to see how things play out this year. Are you familiar, Penny, with VEX Code VR? Have you seen that in any of our? No? Okay, this is fantastic. I'm going to just go through the next 2 slides and then I'm going to jump back to it. So for you working with the actual robots, what you're going to need is you're going to need VEX Code V5. I think we might be up to 2.0.7, but either way, if you go to the VEX Code website, you want VEX Code V5. You do not want the VEX Code Pro. And what that's going to give you is the software that I used during the programming demo, where you can code in blocks or Python or C++. All right, so now I'm going to just switch screens. All right, here we go. Where did my teams go? There we go. And I'm going to give you a quick demo of VEX Code VR. So if we go to vr.vex.com, this is a great way to introduce students to coding, because one of the challenges you have is once the robot's built, you're going to find the students want to drive it around, they want to fiddle around, they want to change things. So this is a great way that students can program a robot on their own without having a robot. It can be done from home. They've got access to it everywhere. So let me just do a new blocks project. So again, this is just a website, vr.vex.com. No login, no sign up. So there's absolutely no reason that students can't access this. They can get on it any place that they've got internet access and a browser. And if we click on the playground button over here, we will notice that we have a virtual robot. Let me just wait for this to load. There we go. So we've got the VEX VR virtual robot, and it has a lot of the same features as the VEX VR. It has a distance sensor on the front. It has a downward facing eye. It has 2 bumper switches. It also has a built-in gyro, and it also has a pen, which is great if you want to do STEAM and add art projects, or if you just want students to trace their path. And this is exactly the same, you'll notice, as the VEX Code V5. So when they open this, whether you start with this or start with the V5 or bounce back and forth because we had to go remote, what's great is the interface is exactly the same. So it's got all the different languages over here on the left side, just in case you've got some students where English maybe isn't their first language, or maybe they're looking for a challenge. It's got example programs, built-in tutorials. These are great. So if your students are starting and they don't understand, how do I get my robot moving? Drive forward and backwards. And what it is, it's a video that actually opens up right in the software, right in the browser. They're all nice and short. This one's 51 seconds long, and it just walks them through step by step of how to do certain things. So an example of this is if you just want to get the robot moving, we can say drive forward for, let's do 800 millimeters, which is 80 centimeters, turn right 90 degrees. And if we hit the run button, you can see our robot is off and driving. So it's a great way to get students started with how do I drive the robot around? We can change the speed the robot drives. Whoops, let's drop that in there. So it drives a little quicker. So it has all of the same functions as their V5 robot. Obviously, the V5 robot has some more sensors. It's got some more functions, but this is a great way to get started. And what's great about this is there are a number of different playgrounds. So this is just a basic grid map. I like to start students on the grid map, get the robot driving around so they have an understanding, then switch to the wall maze. So using those commands that I just showed you, drive forward, turn left, and turn right, they can code their robot through this 3-dimensional maze. And if you're worried about them cheating, or if you want to do a little test, what you can do is it's got some letters and numbers here. So you can throw them a curveball and say, okay, for today's lesson, I want your robot to go to number 2, the letter D, and then to the finish line. And again, it's just a matter of driving forward. Obviously, my code's not going to work because it's a little too long. But it's just a matter of coding the robot step by step to drive through the maze. There are also ones like disc movers. So when we get to more of the competition stuff, like I was saying with the water bottles driving around, what these are blue magnetic discs. So the robot has an electromagnet. So you drive the robot over top of the disc, energize the electromagnet, click, it picks it up, and then return to the box here, de-energize the electromagnet, and it'll drop it back down. Once they've got that down, there's the disc transport. So this, I usually work with my students on the first one, the disc mover, and then the disc transport. They just add a little to it by adding a courtyard with a wall around it. And you'll notice that all of the discs aren't laid out right in front of the boxes. So the students need to work a little harder to get them back in the boxes. One of the favorites of probably all the students out there is the Castle Crasher, because just like it sounds, they get to crash a castle. So they can actually knock buildings over. They can also push them off the edge as well. So let me just drop the speed down. This is a great one also for physics, because as they change the speed of the robot, it does actually have a physics engine where the blocks will fall in a different place, etc. As you can see, they can knock them off the edge. The reason there's a red border all the way around this is because there is no wall. So part of this is teaching students how to write an algorithm where the robot will now look for objects, push them off the edge, but looking down to make sure it doesn't drive off the edge. If you're looking for ideas on how to do that, up near the top next to tutorials, we have activities. And VEX has actually gone ahead and come up with a whole bunch of activities for the different playgrounds. So you can see there's 5 different categories, and here's a list of all the different playgrounds. And then VEX has done up lessons. So for instance, we were just working on Crash the Castle. So if I click on that, again, it opens up in a Google Doc. And what I love about these is it gives them challenges, but it gives them 3 levels of challenges, because we know that not all students love coding as much as I do. So if I usually walk through level 1 with them, and then it's up to the students whether they want to do level 2, level 3, or just improve on level 1. And of course, that's up to you. So for each one of these lessons in the VR activities, it actually gives them 3 different levels of exercises. And again, these are all free of charge. Students, they are Google Docs, so you can use them in Schoology, Google Classrooms, whatever you use, or just tell them, go to education.vex.com/VR, send them a link and say, your lesson for today is secret message, or whatever it is. So again, keep this resource in mind. One, for getting the students started. It's a great resource. Everything is available from the main page, vr.vex.com. And it's a great way to start the students with coding. And heaven forbid, if we do end up in lockdown or remote, you do have something you can still work with the students. Most of the coaches that I've talked to and a lot of the teachers have actually changed up their format where they do the VR coding first. And then they find once the students build the robot, they love the coding. They're already familiar with it. So they dive right in and start coding the robots and having fun with that. This does also have the option, I should mention, just like the VEX V5, there is a help menu. So you can click on any block and it will tell you what that block is, what it does, etc. And there is also the code viewer. So again, this is live, just the same as the VEX V5. Right now it's Python only, but as the students are building their code, it's automatically updating so that students can see what their code would look like in text coding. So that was a lot of information. So thankfully we're recording it. We'll send you a copy of the recording. Do you have any questions about the V5, the VEX VR, the STEM Labs, how to get started, anything at all?
It's very exciting. Yeah, no, I think it's really great. I was trying to do my course overview today, and I think I'm going to start with the 3D printers and then move into the VR, and then I'll go into the VEX 5. I feel like that's
Excellent. That's great. Did you get your 3D printers running?
No, I haven't looked at them yet.
Okay.
And I'm starting with them, so I will soon. I have a meeting tomorrow with our, I don't know if you know, if you've talked to her, Laura. She's meeting with me to discuss the 3D printers, so
Great.
she's done some research for me already.
Great. One thing I should mention, if you want to incorporate 3D printing with the VEX Robotics.
Yeah, that's what I'm wondering.
Okay, it's actually way easier than you'd think. So I'm going to go to motion. I'm going to go to gears. So if students want to, say, make a custom gear or build their own gear, if you go down to the bottom, this is just the regular VEX website. We can go to CAD files. And what you've got is let's see, where's our 30, there's our 36 tooth gear. They actually have the CAD files already for it. So what your students can actually do is download, modify, if they want to make it wider, if they want to change something, or just print it the way it is. It's a great way for them to be able to 3D print their own parts. That being said, I know a lot of teachers like to incorporate it where they're making custom parts. And if we go to structure and just pick any one of these, depending what CAD software you're using, etc., it gives them the actual structure. And now they've got a template for where the bolt holes are, etc. And you could have them build a mechanism or something, or just something add onto their robot that's going to bolt on, going to fit, etc. So again, a lot like real world, where we've got this part, we've got this car or this robot or this assembly, and we need a part that's going to do something else. So all of the CAD files are here as well, so that the students can either take them and modify them or use them as templates.
Cool. That's really great.
Yeah, it does make it really, really easy. So again, another thing I've had some schools and some teams do is a student says, you know what, I need an 84 tooth gear. And rather than trying to buy one for the student, you can literally come here, find the tooth, find the CAD file, and have the student print their own.
Print it.
Yeah. And the 3D printed parts, even with PLA, do work quite well.
Okay. Well, I think that's good for now.
Great. I love your plan.
I have one more question. Okay, so I don't know if you can see my classroom. So we have these 2 boxes, right? This is what I got. 2 boxes.
Yep.
They each got one. So do I just basically give them the book and say, have at it?
That's one way to do it. I mean, that's the way I would start when it came to robotics, is have them all build the exact same robot. And
yeah.
It's up to you whether you want to split it up. I don't know which version of the book you have. Does it have the Speedbot and the Clawbot?
It just says Clawbot.
Okay, so the Speedbot is actually the first half of that. So depending on the technical abilities of your students, I mean, you're grade 9, grade 10, so I don't know if they've built stuff in middle school or the younger grades. I don't know if they've ever seen a screwdriver.
When I look, I did teach them Lego Robotics.
Okay.
We did do Lego Robotics, and they have seen screwdrivers. Last year I did a genius hour kind of thing.
Mm-hmm.
I had to take things apart and build them. But do I need to get screwdrivers?
Nope. All the tools should be in the kits.
That's a good question. Okay.
So what you can do, if you can see my screen still, there is the Speedbot.
Oh, yes.
Which is the bottom half of the Clawbot. So if you think it's going to take them too long to build the Clawbot, now they're grade 10, so it shouldn't really be a problem. But some teachers, especially grade 9, where the students really haven't had much experience, start off with the Speedbot. So they build the Speedbot. Then the students have a robot they can drive around, and they can also code to drive around, especially if you have an inertial sensor. It works very, very well, but it'll still work without it. So that gets them hooked. Now they're excited. Now the next step is finish building the robot so it becomes a Clawbot. They add the uprights, the motor, the claw, etc. Now they've got a full functioning Clawbot. So it's your choice whether you want to start with the Speedbot and do some of those STEM labs, or go right into the Clawbot. Now, that being said, even if you go right to the Clawbot, you can still use it to do most of the exercises the same as the SpeedBot.
Okay.
So it really comes down to, I've had feedback from some teachers that say, you know what, the students were great. We went right to the ClawBot because there was so much more we could do. I've had other teachers say that it would have taken, 3 weeks for them to build the ClawBot. It was better for them to build the SpeedBot, drive it around, have some fun, and then the second part was add the claw.
Okay.
So again, whichever way works best for you.
I'll see how long it takes to do the practice with the VR.
Mm-hmm. Exactly, yes.
Okay.
And then again, a lot of the teachers I work with, they start with the VR and they get the students, so they do it in sequence. They do the VR and they do it together. Then they get the students to code their way through the maze. Then they actually have them build the SpeedBot and build a physical maze, as we talked about before, whether it's just with chairs or tables or, a course in the classroom or out in the hallway, or whether you tape it right out on the floor and make it really specific. And now what they're doing is you're taking that VR lesson and making it into a real lesson with a real robot. And then you can kind of go back and forth. So then you can go back to the VR and do, with the robot that knocks things over and with the SpeedBot, or you can do it with the metal discs, and then doing with the water bottles, the Recycle Rush.
Yeah, I like that.
So you can just keep bouncing back and forth, and that way, and you can give the, I don't know if you're big on homework. Some teachers are, some teachers aren't, but you can always give the VEX VR as homework, where they've got to code that on their own time or as homework or independent study, etc.
And then how do they show me their homework? Is it?
So what I recommend, I get my students to do 3 things. The first thing is, once they've ran their code, let me find the run button, get rid of this. So in this case, this is the Castle Crasher. So if the object was to knock all the buildings over, then what I would do is, once it's done running, is I would get them to send me a screenshot. Do you use Google Classroom or anything like that?
Yeah, we do Google Classroom and Edsby.
Okay, perfect. So in Google Classroom, if they send you a screenshot, you don't actually have to open anything. You can literally, right in Google Classroom, you can look at their screenshot. There's also a share button up here, which is grossly mislabeled, in my personal opinion, because what it does is it creates a PDF of just the actual blocks of code.
Oh, I see. Okay.
But that's a great other way for them to submit, because what that does, that PDF will open up in Google Classroom as well. So you're not downloading anything to your computer. You can literally open it up, scroll through their code and go, yep, that looks good. And then the final thing I do is I do get them to send the actual code. Now, this is where it gets a little tricky. So they have to go File and Save to your device. I don't know if it'll show up here. And what it does is it just saves it to the default folder from the browser. So I'm working in Chrome, so it just saves it to my downloads. Now, the tricky part is, if you want to actually test out their code, you have to go to Google Classroom, download it to your computer, open the website, go to File. Good thing we're recording this, right? And then load from your device, and then you can load in the different code. So it is very tedious if you've got to actually load it in and check it. That's why I asked for a screenshot and the PDF. The other thing I should mention is there is a timer. So when I'm doing something like the maze, I always say to the students who can do it the quickest, the most efficient way. And there is actually a block under Control at the very bottom that says Stop Project. And if I add that and run this, as soon as my code is done, this little timer shuts off automatically. So what that does is that now, we'll see, it turns, drives a bit, turns, and stop. So now when I get my screenshot, I can say, yes, they've done what they need to do, and their final time was.
I like that.
So that's where you get into efficient coding. We recently did a competition with York Region District School Board. We did a VEX VR competition across their entire board. And what we did is we came up with an algorithm where it was the fastest time and the least number of lines of code. So again, all about the efficiency. So feel free to have some fun with that, whether you just add the two together or however you want to do it. And again, when there's a little bit of competition, the students start working together. You can have them in groups, you can have them individually, but they're having a lot more fun.
Love it. Love it. Okay. And so the software to download, I guess I have to get all the kids to do that one too, right? The VEX
Yes.
code.
So do they have all their own computers, or?
Well, some of them are from the school, but they have to buy them from the school. I can get our IT guy to come and put it all on.
So there is, I'm just going to go to it, depending on how it's set up. So this is the site here, and
Okay.
VEX code, yeah, there's, oh, we're on 2.0.8, so I got to update that slide. There is, down here, it says MSI for IT. So
Okay.
first of all, are they Windows computers?
No, they're all Mac.
They're Mac. Okay, your IT guy's probably going to hate us, but that's okay. So again, he can either do a download and push it out if that's the way they're set up, or just give permission so the students can download it and install it.
Okay.
The one thing I will mention for Mac, I don't know if they've got it fixed yet. It was my understanding that it was actually a Mac issue, but you will get students that plug the robot in and it does not connect. And it usually happens after they've plugged and unplugged the robot a few times. The fix for that is reboot the computer.
Okay.
Okay, so if you do get stuck in a student saying, you know what, my robot won't connect, reboot the computer and it always reconnects. It doesn't happen very often, but just a little tidbit just in case it does.
Yeah, good. Thank you.
So yeah, it's just a matter of them downloading the software, getting that ready. And then the VEX VR is easy because it's just a website. They can do that right through Safari. It does work better with Chrome apparently, but I'm sure it works fine with Safari.
We only use Chrome, so it's good.
Oh, perfect.
Yeah.
Fantastic.
Awesome. So excited.
Great. So again, I'm always available for support. So if you do have any questions, anything of that nature, feel free to email me. Sometimes I can just send you a snippet or something, or sometimes we'll just hop in a quick video meeting and work right through it.
Awesome. I noticed that you also help with Spheros because we have Spheros for our lower school. So that's good.
Yep. Yeah, if you do get stuck, by all means. I mean, Spiro's got a lot of resources, but if you are stuck, by all means, feel free to reach out.
Awesome. Okay. Well, thank you very much, Dean.
No problem. Always a pleasure. And again, I know we talked about your 3D printers, so if you do get to them and you do have any questions, if you do need any information, feel free to reach out once you know what kind of printers they are.
And then, okay, once I know the kind of printers, do you help us find the supplies for them, like all the filaments and stuff?
I can probably help out with that, depending on what make they are, etc.
Okay. I don't know how long they've been sitting there, so I don't know how old they are. But
yeah,
I'll let you know tomorrow.
Yeah, I mean, the main thing is, do they power on? That's number one.
Right.
Make, model. Are there any supplies there? That's another thing where you want to look. You want to look and say, what supplies do we have? Because obviously you want to use what you have before you start buying anything new. And then it's just a matter of running some test prints and seeing how well they work.
Awesome.
Great.
Okay, I'm head on into this tech position that I've never done before.
Well, I've been working with teachers for a number of years now, lots in your position. And you know what? It seems like a mountain, but usually after the first year, they're having so much fun and the kids are loving it, you're loving it, and you just evolve to the new tech teacher.
That's it. Okay.
That's it. It's that easy.
Thanks for joining us today, Penny. Really appreciate it.
I thank you for making the exception for today. So busy last week, crazy.
No problem. All right, Penny, enjoy the rest of your day, and we'll talk to you soon.
Okay, bye.
All right, bye-bye.